Now we have learned how to find the Laplace transform of some standard functions. But if the functions are not in the standard form, then how we can find the Laplace? For that, we will see some properties and theorems in Laplace. First, we will see the first shifting theorem. Now, first shifting theorem, the statement is if Laplace of f of t is equals to phi of s, then Laplace of e raised to minus at into f of t is equals to phi of s plus a. Now understand that when we find the Laplace of f of t, we get some function of s. Now if that function f of t, which could be a standard function, if that function is multiplied by e power minus at, then the result we get is phi of s plus a. That means in the original function, the s was replaced by s plus a. So let us see the proof. By definition, Laplace of e power minus at into f of t is equals to 0 to infinity e raised to minus st into e power minus at into f of t dt. Now this e raised to minus st into e raised to minus at, as both have the same base, we can add the power minus st minus at. So minus we will take common and it will be s plus a into t into f of t dt. We consider this as equation 1. Now we have considered Laplace of f of t as phi of s. So phi of s is equals to 0 to infinity e raised to minus st into f of t dt. Now if in this function we replace s by s plus a, we will get 0 to infinity e raised to minus s plus a into f of t dt. Now we can see that in equation 1, Laplace of e power minus at into f of t, we got expression as 0 to infinity e raised to minus s plus a into t f of t dt, and for phi of s plus a, we are again getting the expression as 0 to infinity e raised to minus s plus a into f of t dt. So from 1 and 2, we can say that Laplace of e power minus at into f of t is equals to phi of s plus a. So proof is very simple. We have used only the definition. Now we will see some problems based on this particular theorem. So first problem is find the Laplace transform of e power t into cos 3t. Now as cos 3t is a standard function, we can find out its Laplace by using formula, and this function is multiplied by e power t, so we can use the first shifting theorem which we learned. So now let us begin. We can say that Laplace of cos 3t is equals to, formula is s upon s square plus 9. Now the first shifting theorem is if Laplace of f of t is phi of s, then Laplace of e power minus at is phi of s plus a. Now if in place of minus at we have plus at, so then that phi of s plus a will become phi of s minus a. In this case, Laplace of e raised to t into cos 3t, this we will write as s will replace by s minus a, so s minus 1, e power t means e power 1t, divide by, in denominator also this s will replace by s minus 1, so s minus 1 the whole square plus 9. So the result is s minus 1 upon s square minus 2s plus 1 plus 9, and result we will get is equals to s minus 1 upon s square minus 2s plus 10. So this is your Laplace of e power t into cos 3t. Again we see the definition of first shifting theorem. So we remember, if Laplace of f of t is pi of s, then Laplace of e raised to minus at into f of t is equals to pi of s plus a. Now if I replace that a by minus a, so it will become Laplace of e power minus minus, it will become plus, so e power at into f of t is equals to pi of s minus a. Let us solve one or two more problems. Second problem is, find Laplace transform of e power 4t into sine cube t. Now again sine cube t is multiplied by e power 4t. So first we will find Laplace transform of sine cube t. Now Laplace of sine cube t. Now in standard formula we have seen the Laplace of sine t or cos t. So for sine cube t we have to first express this sine cube t in sine form. Already we have seen how to express sine square in sine, cos square in cos, sine cube in sine. So we will apply the formula and we say that this is Laplace of sine cube t can be written as 1 by 4, and in bracket I will say that 3 sine t minus sine 3t. So this will become 1 upon 4, we can take out, and here we can say that in bracket 3 into Laplace of sine t will be 1 upon s square plus 1 minus Laplace of sine 3t will be 3 upon s square plus 9, that is s square plus a square. So that 3 we can take out and we have 3 divided by 4. Here we have 1 upon s square plus 1 minus 1 upon s square plus 9. Now we got Laplace of sine cube t. So let us apply the first shifting theorem. So what we can say, by first shifting theorem, Laplace of e power 4t into sine cube t, this will be equals to 3 divided by 4 into 1 upon, now this s will be replaced by s minus 4, so s minus 4 square plus 1 minus 1 upon s minus 4 the whole square plus 9. Now we can solve this further, and this will be 3 divided by 4, 1 upon, this will be s square minus 8s plus 16 plus 1 and minus 1 upon s square minus 8s plus 16 plus 9. This will be equal to 3 divided by 4, 1 upon s square minus 8s plus 17 minus 1 upon s square minus 8s plus 25. Now this is equal to 3 divided by 4. We cross multiply and we will get s square minus 8s plus 25 minus in another bracket s square minus 8s plus 17 whole divided by s square minus 8s plus 17 into s square minus 8s plus 25. Now if we open the bracket, we will get this as 3 divided by 4. We simplify the numerator, we open the bracket, s square minus 8s will cancel, and we have in numerator 25 minus 17 whole divided by, in one bracket I have s square minus 8s plus 17, and in another bracket I have s square minus 8s plus 25. So this will give me answer as is equals to 3 divided by 4, 25 minus 17, so 15 minus 7 is 8 divided by s square minus 8s plus 17 into s square minus 8s plus 25. Now this 8 and this here 4, they will cancel and I have 6 in the numerator. So my final answer will be 6 upon s square minus 8s plus 17 in one bracket and s square minus 8s plus 25 in another bracket. So this is how we can find Laplace of e power 4t into sin cube t. Now the third problem is find the Laplace transform of cos hyperbolic 2t into cos 2t. Now here cos hyperbolic 2t into cos 2t, we have separate formula for cos hyperbolic 2t and cos 2t, but when they are in multiple we cannot apply the formula. Therefore here we have to first convert this cos hyperbolic 2t into, if possible, in exponential form. We already know that cos hyperbolic 2t is e power 2t plus e power minus 2t whole divided by 2. So therefore Laplace of cos hyperbolic 2t into cos 2t is nothing but Laplace of e power 2t plus e power minus 2t whole divided by 2 into cos 2t. This will be equals to 1 by 2. I can take out Laplace of e power 2t into cos 2t plus 1 upon 2 Laplace of e power minus 2t into cos 2t. This will be equal to 1 upon 2. Now instead of doing this, let us first see what is the Laplace of cos 2t. We can write the formula directly or we can say this is equation 1. Now Laplace of cos 2t is s upon s square plus 2 square, which is 4. So therefore Laplace of e power 2t into cos 2t, we will say that s minus 2 upon s minus 2 the whole square plus 4. This I will consider as second equation. And Laplace of e power minus 2t into cos 2t, this will be s plus 2 upon s plus 2 the whole square plus 4. This is my third equation. Now from 1, 2 and 3, what we can say that from 1, 2 and 3. Now see what is 1. Equation number 1 is Laplace of cos 2t is s upon s square plus 4. Laplace of e power 2t cos 2t is s minus 2 upon s minus 2 square plus 4. And Laplace of e power minus 2t cos 2t is this thing. Now Laplace of cos hyperbolic t2 into cos 2t is half of Laplace of e power 2t into cos 2t plus half of Laplace of e power minus 2t into cos 2t. So I think this equation I have to consider as equation 1. So first equation we will consider this equation. This is our first equation, and from 1, 2 and 3 we can say that Laplace of cos hyperbolic 2t into cos 2t is equals to 1 upon 2 into s minus 2 upon s minus 2 the whole square plus 4 plus 1 upon 2 s plus 2 upon s plus 2 the whole square plus 4. Now if we simplify it further, we will say that this 1 upon 2 we can take common outside. Here we have s minus 2 upon s square minus 4s plus 4 plus 4 plus here I have s plus 2 upon s square plus 4s plus 4 plus 4. This equals to 1 upon 2. Now this s minus 2 upon this is s square minus 4s plus 8 plus s plus 2 upon s square plus 4s plus 8. We cross multiply and we get s minus 2 in one bracket and s square plus 4s plus 8 plus s plus 2 s square minus 4s plus 8 whole divided by s square minus 4s plus 8 into s square plus 4s plus 8. Now this numerator bracket if we open, this s minus 2 when it multiply by s square. So let us club the highest power first. So this s when it multiplied by s square, it will give me s cube. Now no other term is going to give me s cube. Now in the second multiple, this s will multiply by s square and I have one more s cube. So I will write s cube. Now see what about s square term. So this s when multiplied by this 4s, I will get s square, so I will write its coefficient 4. Then this minus 2 multiplied by s square, so I will say that minus 2. Now here no other term is going to give me s square term. Now in second bracket, this s multiplied by minus 4s, so I have minus 4, and this 2 multiplied by s square, so I have plus 2, and this whole will give me s square term. Plus, now let us see what about s. So this s when it multiplied by 8, I will have 8s. This minus 2 when multiplied by 4, so I have plus 4. Then in second bracket, this multiplied s multiplied by 8, so I have again plus 8, and minus this 2 multiplied by 4, so 4 to the 8, here I have 8. Similarly here in this first bracket also, this is 8 plus 8, so this s multiplied by 8 and this minus 2 multiplied by 4, so minus 2 multiplied by 4 is going to give me minus 8. And here also s multiplied by 8 plus 8 and minus 2, so it will be minus 8, and this is my s term. Plus, now let us see what about the constant term. So minus 2 multiplied by 8 will give me minus 16, and here plus 2 multiplied by 8 will give me plus 16. Whole divided by this whole term divide by, in denominator I will write this as s square minus 4s plus 8 in one bracket, and s square plus 4s plus 8 in another bracket. So finally I will get 1 divided by 2. This s cube plus s cube, I have 2s cube, and rest all terms will cancel as 4 minus 2 minus 4 plus 2, this will become 0, and this 8 minus 8 plus 8 minus 8 will become 0, and minus 16 plus 16 will also become 0. So denominator I have s square minus 4s plus 8 in one bracket, and s square plus 4s plus 8 in next bracket. So finally the result will be this 2 and 2 will cancel, so I have s cube divided by s square minus 4s plus 8 and s square plus 4s plus 8. This is what Laplace transform of cos hyperbolic 2t into cos 2t.